If you're absolutely not prepared for your geometry final exam at all, don't worry, I'm absolutely here for you. We're gonna go through half of a geometry Regents exam together to help you get ready, and also you'll get to use these math songs that we're gonna cover in this video on the test to make math more fun, because it's supposed to be. It's literally the language of our entire universe, and the goal of this channel is to make math more relatable, engaging, and fun through our songs, so let's get started. Is in this diagram below, FAD is parallel to EHC, and ABH and BC are drawn. Also, just letting you guys know, I've not seen any of these questions myself, so this is my first time looking at it, just like what an actual Regents exam would be. So if measure FAB right here is 48, let me draw that, and measures ECB is 18. Okay, what is ABC? Oh, they want to know this angle right here. So maybe we can say that, what do we know about alternate interior angles? Okay, so what we know is alternating interior angles are congruent. They are on opposite sides of the transversal. So we have FAB, which is 48. And so what would the alternate interior angles be? It would be this angle right here, which would be BHC. And then, so we would have 48 here. So what is 48 plus 18? That would be, what, 66? And we also know that a triangle's angle measure is 180. So to find the other angle measure of this triangle, we would do 180 minus 66. So we would get 7. This would be 114. So, oh, my bad. Let me fix that. Okay, so this is 114. And then, what can we see here? This is a 180-degree angle here that these two angles make up. These two angles are supplementary. If we go back to our song, it's like, complementary angles add up to 90 degrees. Supplementary angles add up to 180. So if this is 180, then measure ABC would have to be 180 minus 114. That would have to be 66. So that is our answer. Yay, we're doing so well. The next one is a cone has a volume of 108 pi and a base diameter of 12. What is the height of the cone? So we have the volume of a cone is 1/3 of the volume of a cylinder. So it's 1/3 pi r squared. I think, yeah, it's pi r squared height, yeah. So the base diameter is 12, which means that the radius is 6. So it is 1/3 36 times pi times the height. And so we would have 12 pi h. 12 times 9 is 108. So that the height would just be 9. Now the next thing, we were moving on to the next question here. Triangle JGR is similar to triangle MST, which statement is not always true? Okay, let's draw out this triangle, shall we? Okay, so for my sakes, I'm just gonna make them the same. I'm gonna make this the same kind of size for the triangles. So we have JGR. Normally, whenever you have triangles, you're supposed to draw them like in the order of the angles here. So if it's JGR, you have to draw J first, GR, make sure it goes that order. And then we have triangle MST. And you would usually think that with similar triangles, the corresponding angles have to be congruent. So let's look at it. Which statement is not always true? You got to keep in mind that it's not. So then you would have J could be congruent to M, or it is, so we can get rid of that. R and T definitely are. G and S definitely are. So G and T they might not always be true because they're not corresponding to each other. So 2 we are done with that. Next, in parallelogram ABCD, diagonals AC and BD intersect at E. Which statement proves that ABCD is a rectangle? So let's draw this out, shall we? We have A, B, C, D, diagonals AC and BD intersect at E. Okay, let's draw that out. Okay, I'm sorry that my rectangle does not look good. It intersects at E. Which statement proves that ABCD is a rectangle? We know that it is a rectangle if you have 4 sides and you have 90-degree intersections. So we have AB, AC. Yeah, if the diagonals are the same, I'm pretty sure we know AC bisects yeah, we're just gonna go with this. The endpoints of directed line segment PQ have coordinates of P 7, 5 and Q, which is 5, 3. What are the coordinates of point A on PQ that divide PQ into a ratio of 1, 3? We are going to find the midpoint because the midpoint's at the halfway mark. So we need to, so then there have to be a point that's closer to P for it to be 1 to 3, the ratio of 1 to 3. So yeah, let's find the midpoint. So then let's look at our song on how to find midpoint. So it's take the x1 and add by x2, then divide by 2. So we would do, we would have -7 plus 5. And then you would have -2. And then you would divide this by 2 and you would get -1. Now let's do the same for the y, which is the same version of the song. So it's like take y2, then add by y1, then divide by 2. So then you have -5 plus 3, which is -2, and then you divide by 2, and then you get -1. This is the midpoint. We're at the halfway point. We need to be at a ratio of 1 to 3, which means we have to be like 1/4 of the way there. And so because of that, we want this to be closer to the value of P. And so what this means is we only have this value right here, which can do that. Next, let's do number 6. In trapezoid ABCD, below AB is parallel to CD, which means they have the same slope and they never intersect. If AE is 5.2, AC is 11.7, and CD is 10.5. What is the length of AB to the nearest tenth? So what is the length of EC right here? That is just 11.7 minus 5.2. That is 6.5. 6.5. Okay, so we know that these two triangles are similar triangles. Because of that, you just have to do a simple ratio and proportion. We got 6.5 over 10.5 equals x over, wait, no, we would do 5.2 over x. We can do a very simple thing here. If x is on the bottom side, what we have to do is cross multiply. I know it's not a song, it's just a rhyme, but definitely use that instead of like trying to multiply both sides by x and do all of that. So we have 6.5 x equals 10.5 times 5.2. If you have a calculator, please definitely make use of it when we do order of operations in reverse. And if it's multiply, you divide, you would get 8.4, which is the length of AB. Kayla was cutting, okay, now let's move on to problem 7. Kayla was cutting right triangles from wood to use for an art project. 2 of the right triangles she cut are shown below. If ABC is similar to DEF with right angles B and E, BC is 15 and AC is 17, what is the measure of F to the nearest degree? F has the same degree as C. What do we have here? The adjacent side and the hypotenuse. What relationship of an angle is adjacent over hypotenuse? Cosine is adjacent over hypotenuse. Take the side that's adjacent, set it over the hypotenuse. So we have cosine of C equals 15 over 17. And in order to get this angle measure by itself, you would need to do arc cosine, which is available on your calculator. So you do arc cosine 15 over 7, and you will get your measure in degrees. Make sure that your calculator is set in degrees and not radians, because all of your answer choices are in degrees. Just keep that in mind. Okay, now let's move on to question 8. The line represented by 2y equals x plus 8 is dilated by a scale factor of k centered at the origin such that the image of the line has the equation of y minus 1/2 x minus 2. What is the scale factor? Okay, now what can we do here? We have this equation is something that's kind of written in standard form, kind of. These are all the parts of standard form, ax plus by equals c. This kind of is like slope-intercept form because it's in the form y is mx plus b, y is mx plus b, m is the slope of the line, while b is the y-intercept. So what we can do to find out the scale factor means that these equations are multiplied by something that is constant. Okay, what we can do here is make sure that everything in both equations are positioned the same way. So we have 2y equals x plus 8. And then you have y equals 1/2 x plus 2, I think. Okay, so what is the scale factor? The scale factor here is it's going from 1 down to 1/2, and 1/2 is half of 1. So the scale factor here is you're going down by 1/2. So the answer would just be 1. Now let's move on to 9. In quadrilateral ABCD below, AB is parallel. Wait, no, AB is parallel to CD, and E, H, and F are the midpoints of AD, AC, and BC, respectively. If AB is 24, CD is 18, and AH is 10, then FH is... Okay, so this is basically the triangle mid-segment theorem. That's one that we have to use here. So, okay, I guess a nice little rhyme/song you can use is, if the mid-segment gives you the blues, then you divide by 2. Okay, we have 24, which is AB, and then we have HF, which is the mid-segment. So 24 divided by 2 is 12, and so our answer would just be 3/12. Now let's move on to question 10. Jaden is comparing two cones. The radius of the base cone A is twice as large as the radius of the base of cone B. The height of cone B is twice the height of cone A. The volume of cone A is... Okay, so let's write this. The easiest way to do this is to plug different numbers in and then see what we get out of it. So what is the volume of a cone again? It is 1/3 pi r squared height. So I guess one easy way to remember this is to find to find the area of a cone divide the area of okay, so it's to find the volume of a cone, divide the volume of a cylinder by 3, the answer you got with glee. Yeah, you can just use something like that. Now let's plug in random numbers. For our sakes, let's just do 1 and 2. So the radius of cone A is 1, and then the radius of cone B, wait, no. It says the radius of the base of cone A is twice as large as the radius of cone B. So let's say the radius of cone B is 1, and then the radius of cone A is 2. The height of cone B is twice the height of cone A. So let's say the height of cone B would be 2, and then the height of cone A is 1. So let's find the volume of both cone A and cone B. So with volume of cone B is 1/3 pi r squared height. So we have 2/3 pi, right? Because the radius of cone B is 1, and so 1 squared is just 1, and then you multiply that by pi, and then the height is 2, so then you get 2, and then you divide by 3, that's 2/3. So what is the volume of cone A? Okay, so we have the radius of cone A is 2, so when you take the square of that, it is 4, and then the height is just 1, so it's 4/3 pi. The volume of cone A is twice the volume of cone B. Now let's move on. A regular hexagon is rotated about its center. Which degree measure will carry the regular hexagon onto itself? One thing that you need to remember is like 60 degrees, 120, 180, like all of those are good ones to carry a regular hexagon onto itself. So you would just answer with 3. Okay. In the triangle MAH below, MT is the perpendicular bisector of AH. Okay, so if it's a perpendicular bisector, what do we know about perpendicular lines? Perpendicular lines intersect at a 90-degree angle. I'll put the link to that song in the card so you can watch it. But anyway, now you know that these two angles right here, MTA and MTH, are both 90 degrees. We can say which of the following statements is not always true. A and TMH. Okay, A and TMH are complementary angles. Yeah, I am sure. Yeah, that is definitely true. MAT is isosceles. And then okay, you have, let's say you have MT bisects AMH. It does, because you can clearly see it here. Okay, let's say MAT is isosceles MAH. MAT does not always have to be isosceles. And MAH obviously has to be, because the perpendicular bisector is splitting this triangle. Yeah, MAH. In order for the perpendicular bisector to intersect right in the middle, these two have to be the same. So then that leaves us with MAT is not always isosceles. It can be, but it does not have to be, because this, in circle B below, diameter RT, radius BE, and chord RE are drawn. If MTRE is 15 and BE is 9, then the area of sector EBR is, okay, let's see what this is. TRE is 15, BE is 9, so we need to find the area of this sector right here. We can do that. So this right here is 15 degrees. What does that mean? That means that this is an inscribed angle. What does the inscribed angle theorem say? It says that this is twice of that. So this is 30 degrees. RT is a diameter. That means the central angle is 180 degrees. What is 180 plus 30? 210. Meaning that this part right here is 150 because a circle's degrees is 360. Okay, now that we have this, now we need to find the area of sector EBR, and I think we have all the information that we need. So I guess if you look at our song about circles, it is circumference is diameter times pi. Area is pi times radius squared. Yes, I know, it's a parody of Circles by Post Malone. Anyway, we're going to continue on. We can do this by setting up a proportion. We would say, okay, 150 over 360 has to equal x, which is the variable that we're solving for, over what is the area of this entire circle. If area is pi times radius squared and the radius, which is BE, is 9, so pi times the radius, which is 9 squared, that is 81 pi. 81 pi. Yeah, this is the whole circumference, this is the whole area of the circle. Now we need to solve for x, and according to our song about solving equations, this is a callback to algebra, where it's order of operations in reverse. Let's solve this with pride. If you see a minus sign, you add, and if it's multiply, you divide. So we see 81 pi here, which we need to multiply both sides by 81 pi in order to isolate x by itself. So we would have 150 times 81 pi divided by 360, that equals x. Okay, now we can do a whole lot of simplifying here. We can get rid of the zeros because we're just dividing by 10. 15 and 36 are both divisible by 3. So 3 times 5 is 15. 3 times 12 is 36. And then you multiply, and then you have 81 pi right here. 12 and 81 are both divisible by 3. So we got what? 3 times 4 is 12. 3 times 27 is 81. So then we have 27. We have 5 times 27 pi over 4. What is 27 times 5? You can easily plug this into a calculator. 5, 30, 135. So it's 135 pi over 4. Now that we have that, we can do 135 over 4 pi. We have 4 times 3 is 12. Four times 3 is 12 again. 4 times 7 is 28. And then we end up with 5. So the answer is 33 0.75. That was a big problem. Now let's move on to 14. Lou has a solid clay brick in the shape of a rectangular prism with a length of 8 inches, a width of 3.5 inches, and a height of 2.25 inches. If the clay weighs 1.055 ounce per inch cubed, how much does Lou's brick weigh to the nearest ounce? Okay, what is we are dealing with units of volume here. So we have to do length times width times height to find volume. Those are all the steps you take. That's right. Let's multiply each of these by each other. This is a calculator solvable problem. If you're allowed to use a calculator, all you would have to do is to multiply 8 times 3.5 times 2.25, multiply all that by 1.055, and then round it to the nearest ounce. You have your answer that way.